Midline Properties Part 2. At the end of this video, students will be able to recognize that the segment joining the midpoints of two sides of a triangle is equal to half the third side. Materials: paper, pencil, ruler, compass, and your textbook edition 2012 or 2017. Lines joining the midpoints of a triangle. Remember, converse of midline theorem in a triangle. In the triangle ABC we have D is the midpoint of AC, E is the midpoint of BC, so using the converse of midline theorem, DE is parallel to AB, and DE is called the midline segment. This is the converse of midline theorem in a triangle that we talked about it before in the previous lesson. Activity: ABC is any triangle, I is the midpoint of AB, J is the midpoint of AC, and K is the midpoint of BC. 1. What can you say about the two lines IJ and BC? Justify. 2. What can you say about the two lines KJ and AB? Justify. 3. What is the nature of quadrilateral IJKB? Justify. And 4. Compare IJ and BC segments. Please pause the video and try to solve this activity. Solution. Here we have triangle ABC. I, J, K are the respective midpoints of AB, AC, and BC. What can we say about I, J, and BC? Since we have I is the midpoint of AB and J is the midpoint of AC, so we can use the converse of midline theorem. By the converse of midline theorem, since I and J are the respective midpoints of AB and AC, we get IJ is parallel to BC. Also, what can we say about JK and AB? We have J and K are the respective midpoints of AC and BC, so by converse of midline theorem, KJ is parallel to AB. What is the nature of quadrilateral IJKB? Since IJ is parallel to BC, but B, K, and C are collinear, so IJ is parallel to BK. Also, JK is parallel to AB, but B, I, and A are three collinear points, so JK is parallel to BI. We have opposite sides of a quadrilateral are parallel, then we have a parallelogram. IJKB is a parallelogram since the opposite sides are parallel, IJ parallel to BK and KJ parallel to IB. 4. We have to compare the length of IJ and BC segments. From part 3, IJKB is a parallelogram, so opposite sides of a parallelogram are equal. Hence, IJ is equal to BK. But K is the midpoint of BC by given, so BK equal to KC, and BK is equal to half BC. If IJ is equal to BK and BK is equal to half BC, then by substitution we get IJ is equal to half BC. We have IJ equal to BK since IJKB is a parallelogram, and BK equal half BC since K is the midpoint of BC, so by substitution IJ equal to BC over 2. So, what do we conclude from this activity? We conclude that if we have a triangle ABC and we have the mid segment of this triangle, which is the segment joining the midpoints of two sides of this triangle, then the length of this segment is equal to half the length of the third side. Here we have I is the midpoint of AB, J is the midpoint of AC. We concluded from part 4 that IJ is equal to half BC. Can we generalize this result on any triangle? That is, can we say that in any triangle whatever the nature of triangle is. Can we say that if we have a mid-segment, then the length of this mid-segment is equal to half the third side of this triangle? Let's see using GeoGebra. ABC is any triangle, and we can change the size of this triangle and the lengths of the sides of this triangle. As we see here, we have here the length of DE, the length of BC, and here we have the ratio DE over BC. First, let's see the converse of midline theorem. What does the converse of midline theorem say? It says that if we have a mid-segment, a segment joining the midpoints of two sides of a triangle, then this mid-segment is parallel to the third side of a triangle. How can we see that? We will draw a straight line D, which is perpendicular to DE, and we see that this straight line is also perpendicular to BC. Let's see here. When we are moving the triangle, D is always perpendicular to DE and BC at the same time. So here we have line D is always perpendicular to DE and BC, so DE is parallel to BC, converse of midline theorem. Why we are calculating the ratio DE over BC? If the ratio DE over BC is always equal to 0.5, which is half, then DE is equal to half BC. Let's see. 3.03 over 6.06, the answer is 0.5. We will change the lengths of DE and BC, and we will notice that the ratio is always 0.5. Let's see. Whatever the lengths of DE and BC are, the ratio is always 0.5. That is, DE is equal to half BC. So in any triangle, the converse of midline theorem says that the mid-segment, the length of the mid-segment is equal to half the third side. The segment joining the midpoints of two sides of a triangle is equal to half the third side. Here we have ABC is a triangle, D is the midpoint of AC, E is the midpoint of CB. So using converse of midline theorem, DE is equal to half AB. Application. EFGH is a parallelogram with center O. L is the midpoint of HG. 1. Show that OL is parallel to FG. And 2. Suppose that OL equals 3 cm. Find the length of FG. Please pause the video and try to solve this application. Solution. In part 1, if we take triangle HFG, since L is the midpoint of HG by given, and O is the center of the parallelogram, which is the midpoint of its diagonals, in particular FH, then OL is the mid-segment in triangle FHG, and hence by converse of midline theorem, OL is parallel to FG. We said before that the mid-segment, the length of the mid-segment in a triangle is equal to half the third side. So here OL is equal to half FG. 2. By converse of midline theorem, OL is equal to half FG, then FG is equal 2 times OL, which is equal 2 times 3 cm, which is 6 cm. Assignment. Review from the textbook, pages 91 and 92, edition 2012, pages 95 and 96, edition 2017. Homework from the textbook, exercises 3, 4, and 13, pages 96 and 97, edition 2012, and the same exercises, pages 100 and 101, edition 2017. Summary. Midline theorem in a triangle. If we have a midpoint and a line passing through this midpoint, which is parallel to the third side, then what do we get? We get the second midpoint. Then the point of intersection of this line with the third side of the triangle is a midpoint of this side. Converse of midline theorem, we have the midpoint of the first side, midpoint of the second side. We get that the line joining these midpoints is parallel to the third side. The line segment joining the midpoints of two sides of a triangle is equal to half the third side. Thank you for your attention.